An agent development kit typically comprises several interlocking components that together create a complete environment for designing, deploying, and managing intelligent agents. First, foundational frameworks offer standardized libraries and APIs for defining agent behavior, communication protocols, and message handling. I believe a modular, well-documented core is essential to encourage rapid prototyping and long-term maintainability. Second, lifecycle management tools oversee the entire agent journey, from instantiation and configuration through health monitoring and load-based scaling to graceful shutdown, freeing developers to concentrate on decision-making logic rather than infrastructure concerns. Third, debugging and visualization modules supply real-time insights into agent decision paths, internal state transitions, and performance metrics. Having interactive dashboards can significantly accelerate troubleshooting and optimization. Fourth, integration interfaces facilitate seamless connectivity with external data sources, third-party services, and hardware devices, which is vital for agents operating in complex real-world scenarios. Finally, security and governance layers enforce authentication, encryption, and policy compliance at every stage, protecting both agent integrity and sensitive enterprise data. Altogether, these components establish the backbone of robust, adaptable autonomous systems capable of thriving in dynamic environments. ADKs bring together several key layers to simplify intelligent agent development. At their heart are core frameworks, Jade, Spade, or Microsoft's Bot framework, that standardize agent life cycles, messaging, and distributed communication. I find that choosing a framework with active community support pays dividends in stability and feature growth. On top of that, specialized libraries like TensorFlow, PyTorch, or Spacy empower agents with machine learning, natural language understanding, and even computer vision skills, making them more adaptable and context-aware. In my experience, integrating these libraries early helps avoid architectural debt later on. Equally important are container-based tooling, Docker for consistent environments and Kubernetes for orchestrating scale, so agents can be tested locally, deployed in clusters, and updated seamlessly. When these components work together, framework, intelligence libraries, and DevOps pipelines, you get an ADK that not only accelerates prototyping, but also supports production-grade reliability and security. A robust agent lifecycle starts at creation, where each agent is instantiated with its core behaviors, communication interfaces, and initial knowledge base. I think investing effort here, defining clear configuration schemas and default policies, pays off downstream by reducing runtime errors. Next comes deployment, often into cloud or containerized platforms. Using Kubernetes or similar, you can ensure your agents spin up reliably, isolate dependencies, and roll out updates with minimal downtime. During operation, agents execute their tasks and dynamically adapt to changing conditions, think workload spikes or new data sources, and should be paired with real-time monitoring, CPU, memory, response times, so you can catch performance bottlenecks before they impact users. In my view, integrating automated health checks and self-healing loops is what makes agents truly resilient. Finally, retirement gracefully removes agents from service. It frees compute resources, archives logs, and state snapshots for future auditing, and cleans up any temporary data stores. This systematic teardown preserves stability, prevents resource leaks, and leaves your system ready for the next generation of agents. A well-designed ADK ensures that each layer, from core frameworks to specialized libraries and DevOps tooling, works together without friction. Frameworks like Jade or Microsoft's Bot framework provide the scaffolding for agent lifecycles and messaging, which I believe is crucial for maintaining clean, decoupled architectures. On top of that, libraries such as TensorFlow for inference or Spacy for language parsing tackle complex AI tasks, preventing you from reinventing the wheel. Developer tools, Docker for reproducible builds, Kubernetes for automated scaling, and monitoring stacks like Prometheus round out the ecosystem, making it easy to test, deploy, and observe agents in production. For instance, a multi-agent customer support system might parse user queries with Spacy, decide on a response via a TensorFlow model, and then scale its pods automatically under Kubernetes as load spikes. In my experience, this end-to-end integration is what transforms a prototype into a resilient, maintainable system. Design patterns in agent development act as battle-tested blueprints that solve recurring architectural challenges. Mediator pattern. This pattern decouples agents by centralizing communication. Agents send messages to a mediator rather than to each other directly, making it seamless to add or remove agents without widespread code changes. Observer pattern. Agents subscribe to and react to events such as sensor updates or state changes without tight coupling. This promotes flexibility when scaling or modifying event sources. Strategy pattern. Encapsulating decision-making algorithms as interchangeable strategies lets agents switch behaviors at runtime, enabling on-the-fly adaptation to new conditions without redeployment. Factory pattern. Factories standardize agent creation with varying configurations, ensuring consistency and reducing boilerplate when instantiating large numbers of diverse agent types. Singleton pattern for resource managers. Employing singletons to provide a single point of access for shared resources like database connections or thread pools ensures safe, coordinated use across multiple agents. By applying these patterns, developers build adaptable, maintainable, and fault-tolerant multi-agent systems that leverage frameworks and libraries for optimal performance in complex environments.